Hey there, today I'm going to show you how to create a microservice application in Nest.js using Kafka.js as the transporter. So we're going to have an API gateway and then two other Nest.js applications that are all connected together through Kafka. Now I have another video on setting up microservices through TCP. And so now we're going to walk through and see the differences using Kafka. So the first thing we're going to want is the ability to run Kafka on our machine. And also I like to use the tool called KafDrop, which is a web GUI for Kafka. It allows us to view the topics we've created and see the messages on each topic. So you can feel free to run Kafka any way you'd like, but we're going to use Docker Compose in this video so that we can run KafDrop and Kafka at the same time. So I have this GitHub repo here, and I'll include the link in the description. So we can simply copy the clone URL here, and then in your terminal you can run git clone and then clone the KafDrop repository. So once you've cloned the repository, let's cd into KafDrop, and now we're going to run cd docker compose kafka KafDrop. So we're in the Kafka KafDrop folder, and then we can simply run Docker Compose up. And of course, you'll need to make sure you have Docker installed and running on your machine. So let's run Docker Compose up, and we should see Kafka as well as KafDrop are starting up in our terminal here. Now, if you give it a few seconds, when we go back to our browser here, you should be able to navigate to localhost 9000. And you actually have a web GUI now to view all of your Kafka topics, which will be useful for debugging your applications when you work with Kafka. So now that we have our Kafka server running, you're going to want to open up three different terminals or three additional terminals and cd into whichever directory you want to create your application in. And this is because we're going to have three separate Nest applications all running at the same time. We're going to want three different terminals. So first, we're going to start off by creating our API gateway. So I'm going to use the Nest CLI to generate a new project, and we'll call this Nest New API Gateway. So this API gateway will be responsible for actually receiving HTTP requests and then sending or emitting events to our different microservices. So I'm going to use Yarn to set up this package. So we can let this continue. In the meantime, we can generate the other project. So run nest new, and this will be a new package we'll call billing. So we'll imagine that our API gateway will allow for order creation. So you can create a new order and a post route in our API gateway. And then in order to bill the user for creating a new order, we're going to emit event to the billing microservice, which will take care of charging the user. So lastly, we're going to have one more microservice. So we'll call Nest New, and we'll call this auth. So this microservice will host all of the information about the users in our application. So that, for example, when billing is trying to charge a user, it needs to know which user to charge and get their, for example, Stripe ID if we're using Stripe to charge the user. So it's going to reach out to the user's microservice and get that user so it can properly charge them. So with the API gateway all set up, we can cd into it, and we're going to have to install a couple of packages into each one of these microservices. So we can run yarn add, of course, Nest.js Microservices, as well as Kafka.js. So we can actually just copy this line here and make sure we run that. We'll do the same thing here. We'll cd into billing, add Nest.js Microservices and Kafka.js, because this will be our transport. And then lastly, for auth, we'll do the same thing. So now that we have all of the required packages we need, we can go ahead and run yarn start dev in each of these APIs. So at this point, we should have our Kafka server running, and then we should have three Nest.js applications all running, and we can just disregard the error messages about the address already in use, because we won't be listening over HTTP in these apps after we change them. So I've gone ahead and opened the API gateway up in VS Code. I'm also going to open up the additional apps as a workspace folder. So you can see here, I'm going to add auth and billing as folders to our workspace so that we can have all three projects listed like so. So let's go ahead and start with our API gateway. This is going to be responsible for actually emitting an event to our billing service. So first of all, let's go ahead and create a post route that we can use to initiate this flow. So this will be, for example, a create order route, and it'll take in a create order request. So we can add a create order request.dto, and so we'll export a class create order request, and this will take in the user ID of the user that created the order, and then we'll have a price here that we're going to charge the user. So back in the controller, we can specify that this is the body, and we know this is the create order request of type create order request. So we're going to dispatch this action to the app service, and we'll have a new function in there called create order, and we'll pass in the create order request. So let's go into the app service and set this function up. So in here we'll have the create order function, and inside of this create order request we can pull out the user ID and the price, which is what we'll need, and it'll be a type create order request. So in this function, the create order, we could of course persist some information to our database, but then what we want to do is we want to emit an event to the billing service down here for it to actually handle the charging of the user, because anything to do with payments or billing is going to be associated with this microservice, and it's a separation of our concerns. So we really just want to emit an event with the user ID and the price here so that the billing service can handle it from there. So in order to do this, we need to get a handle to the billing service. Now let's open up our app.module, and in here, this is where we actually set up our communication, our Kafka communication to our external microservices. So we're going to use the clients module, which we import from Nest.js Microservices, and then we're going to call register, which takes an array of the different services that we want to allow for injection. So the first one we'll give a name, and this is going to be the injection token that we can use later on in our service. So we'll call this billing service because this is the name of the service. And then we specify the transport. So in this case, we know, of course, we're using Kafka. And then we have an options array here. So in the options array, we have a client object, and then we can specify the client ID for the Kafka consumer. So in this case, it's billing. We'll call it billing. And then we can specify the brokers that the Kafka server is listening underneath. And of course, that's going to be localhost 9092 by default, which is where our Kafka server listens. Now we also are going to specify the consumer object here and specify the group ID for the billing consumer. So we'll call this billing consumer. So now we have a configuration set up for the billing service. We can actually go back into our app service and use this. So let's go ahead and inject this, and we'll add the constructor here, and we can add the inject param decorator that takes in the injection token, which of course we know is billing service. So this is going to be a private read-only billing client is what we'll call it, and this is going to be of type client Kafka. So now we have a handle to this billing client. We can actually emit an event here. So let's emit an event, and as it does in the TCP transport layer, we have the same parameters that this emit takes in. We have the pattern. So in this case, we'll have order created as our pattern, which essentially will just be the topic. And then we can specify a data payload. Now we need to actually create an event. So I'll do that. We'll have a order created dot event. So this will be a class we'll export called order created event. And the constructor, so in the constructor, we're going to take in a read-only, say we'll call it order ID type string, and then we'll add the user ID type string as well, and then finally the price, everything that the billing service is going to need to know in order to build the user. So now that we have all these properties on the event, there's one more thing we need to add. So by default, if we just provide a plain object as the payload here, Nest.js will simply stringify this and all will be well. However, if we use something else like a class, Nest.js will call the toString method on that class. So if you don't have this implemented in your class, none of the properties on it will actually get transmitted. So in order to resolve this, we can actually implement our own toString method on this class, which will be simply a JSON.stringify with all of the properties that we have in our class. So now that when Nest calls toString on this class in order to serialize it, we get all the properties being sent to the billing service. So now we can specify a new order created event, and we can pass in the order ID. I'll just use 123, and then we'll pass in the user ID and the price. So now that when we create a new order, we are correctly emitting a message to the billing client using Kafka topic order created and passing in the order created event here. So now we need to set up the billing client to actually be able to listen for incoming messages over Kafka. So let's go ahead and open up the main.ts in our billing application. And we can remove all of the boilerplate in the bootstrap method. And as we've done in my previous video with TCP, we're going to instantiate a create microservice here with microservice options. Okay, and so we're just creating the microservice right now. Instead of over HTTP, we're going to be listening over the Kafka protocol. So we'll pass in the app module here as the first parameter, and then an object here with all of the options. So of course, we can specify the transport, which we know is Kafka, and then the options object as we've done in our client. So we have the client object here where we can specify the brokers. We know that we're going to be listening on localhost 9092. And lastly, importantly, we're going to add the consumer property, and then we're going to call the group ID and give it the same group ID that we specified in the client. Now this is important for this billing service to be able to pick up messages properly. We need the same group ID that we specified previously in our client. So finally, we'll call app.listen here. So now that we are listening for messages on the billing consumer. So let's go ahead and open up our app.controller so we can actually add a route here for the order created event. So we'll add the event pattern decorator here that takes in the pattern or the topic name. So in this case, we know it's going to be order created, and we can call this handle order created. So we're going to get the actual Kafka message here that we'll call data, and then we can call this .appService.handle order created, and I'm going to pass in data.value, which is where the order created event actually lives. So the value property is where the payload will be living. The other information on this data property here will just be Kafka related, like the offset, topic, partition, and so on. But we're only concerned with the data payload right now. So let's go ahead and open up our app service now, and we'll create a handle order created function that takes in the order created event. So we're going to have to specify this like we've done before. This will be called order created event. And I'm just going to go ahead and copy over the constructor from our other order created event because it's the same thing here. So then we can specify the type here, order created event. Now for now, let's just go ahead and log out the order created event to see that our microservices are set up properly. So go ahead and open up Postman and then send a request, a post request to localhost 3000, which is where our API gateway is listening for that handle order created. And in our body here, we include the user ID, the price, and some extraneous property that I can remove here. We don't need that. So if we send off this post request to our API gateway a few times and then go back to our terminal here, we should see that our billing client or a billing service is logging out the order created event properly as we'd expect. Now, if you're not seeing this message here, make sure you wait until you see this log message from Nest that the microservice started successfully, because sometimes it can take a little bit for the service to actually rebalance and join the consumer group. So now that we actually are receiving the order created event, we need to reach out to our auth service and get the user associated with this event so we can get their Stripe billing ID. So as we've done before, we're going to need to set up a handle to a different external service. So as we have already done, we will specify the client's module register function here and pass in an array, and we'll just want a single service here. So we'll call this auth service. Okay, and of course the transport will be transport.kafka. And then as we've done before, we'll specify the options object with the client object inside. We'll give it a client ID of auth. We'll list the brokers out here. In this case, it's just localhost 9092. We'll add a consumer object here with the group ID. We'll give it name auth consumer. So now we have registered this service in our app service as we have already done. In our billing service, we're going to inject this here so that we can use it. So I'll have the inject param decorator here, and we'll include the auth service injection token. So this will be private read-only auth client this time, and this will be client Kafka. So now we have a handle to the auth client. We need to reach out and actually get a response back this time, which is a little different because with the event pattern, we didn't care about the response at all. So in Nest.js, with the Kafka implementation, in order to get a reply back, a reply is actually its own topic. So we send a message on a separate topic, and then we receive a message back from the auth service on a different topic. So we need to tell Nest.js to actually subscribe to that reply topic. And in order to do that, in our app controller, we will say that we want to implement onModule init here, onModule init, and then we will implement onModule init. And we need to get a handle to the auth client like we've done in our app service. So we can copy this injection here and paste it in after our app service, and make sure we import the inject and the client Kafka here. So then we need to call this auth client.subscribe to response of, and this is going to be the topic that we want to subscribe to the response of. Okay, and in this case, it's going to be called get user. Now this is the topic that we're going to use to send a message to the auth service, and we want to subscribe to the reply topic. And Nest.js will automatically do this for us. The topic ends up being just the name of the topic and then reply. But we just need to include the original name of the topic here, which will be get user. So let's go back into our app service now. Now that we're correctly listening for replies, we can call this .auth client.send. Okay, so send will actually send a message to a service and then wait for the reply back. So we'll specify the pattern here, which of course we know we just set up as get user, and then we have the actual payload that we want to send. So let's go ahead and set this up. We're going to need a get user request now. So I'll create a new file here called get user request.dto, and this is going to be a simple class get user request with a constructor, and all it's going to take is the user ID that we want to retrieve. Now don't forget, since we're using Kafka serialization, we need to implement our own toString method here. So we'll return json.stringify and just provide the user ID so that Nest will serialize it properly. So back in our app service, we can actually now create a new get user request, and we'll pass in the order created event user ID. So importantly, Nest.js, it won't actually send this message. Unlike events, where it just fires and forgets immediately, messages, in case where we're using the send function here, doesn't get sent until we actually subscribe to the response. So we actually do want to subscribe here. We get the user back. So let's get the user back from the auth service, and then we will log a message out. Let's say we will be billing user with Stripe ID, and this user will have a Stripe user ID on it. And we'll say for a price of $, and then we'll pull the price off of the order created event, and we'll add a few dots here. So our message ends up becoming billing user with Stripe ID and a price of price. Now that we're successfully handling this order creation, and of course here this is where we'd actually reach out to the Stripe API and bill the user. But for sake of example, we don't need to actually implement that. But we do need to go ahead and set up the auth client. So now let's go ahead and finally set up our auth service to be able to listen for incoming messages. So go ahead and open up the main.ts for auth. To save some time, let's actually copy over the existing one that we implemented for the billing service. I'm just going to copy over this whole main.ts, paste it in here. And the only thing we're going to change is the group ID here. We're going to call it auth consumer, which, if you recall, needs to be the same that we used in our app.module here. So next, let's open up our app.controller. And instead of the event pattern this time, we're going to use the message pattern decorator, which similarly takes in the message pattern, which of course is get user, which will be the name of the topic that Nest.js is using. So we'll have get user here. We'll get the whole data payload, and we will return. Now we're actually returning a message, appservice.getUser. And as we've done before, we're going to pull the value property off of this data payload. So now in our app service, let's go ahead and implement the getUser function, which will be very simple. We'll actually have the getUser request as well. So we'll create it real quickly, getUser request.dto. And as we've done before, I'm just going to copy over this request from our billing application. So now we can specify the get user request here. I'm actually just going to go ahead and create a simple in-memory array here of users. So I have a private read-only array with a couple of user IDs and their associated Stripe user IDs. So now in our get user function, I'm just going to call this.users.find. Based off a user, I'm going to compare the user.user ID and see if that equals the get user request user ID. So this will simply just pull out the correct user from this array. So go ahead and open Postman back up, and let's go ahead and send off a few different requests here. So we have user ID 345, and then we also have user ID 123. We can even change the price here. So we'll send off a few different requests. So now if we go back to our logs, we should see that our billing service is correctly logging out this log here, billing user with Stripe ID, and the price. Now we can see that we've actually correctly implemented a Kafka.js microservice architecture. I've shown you how to use the event pattern and the message pattern to communicate between these microservices. So I hope you've learned something in this video and it's been helpful. If you have any questions, please post a comment. Be sure to like and subscribe, and I'll see you in the next one.